Okay, this time I want to cut a chamfer on the other side of the part using the side of the 1-inch end mill. I'm going to put a 1-inch chamfer down that left side of the block. Notice that the tool is going to tilt in the same direction as it did on the other side. I'm still going to tilt the tool in a positive 45 degrees. So just because I'm on the left side of the part does not mean I have to tilt to a negative side. That's just a rule of thumb to tell me that left side of the part, if I'm tilting in that direction, is going to be a negative rotation. But here I need to tilt in a positive rotation to get the side of the end mill where I want it. Just like the other side, I'm going to move to a corner of the feature, pretty much the same corner that I did on the other chamfer, only on the left side of the part. So this time my origin point in X is going to be a negative number. I'm going to put negative 2 inches because I want to put a 1-inch chamfer. I'm going to stay 1 inch shy of that left side of the part. So I'm not going to go the full 3 inches in negative from the center to the left side. I'm going to stop an inch short. So my X is going to be a negative 2. My Y is still going to be a negative 3. And my Z is still going to be 0 because I'm not moving at all. And now look at our X and Z here. When I rotate from that point, or around that point, positive 45 degrees, you can see that the X now rotated the same direction it did on the other side. So when I go to program my X, Y, and Z, I need to be conscious about the direction that it rotated. So anything X positive is going to cut into the part. Anything X negative will be away from the part. So I need to be aware of that. So how are we going to go ahead about programming that? Well, just like everything else, I'm going to start with a transform plane. Insert, rotary, transform plane. I'm going to move minus 2 inches in X. I'm going to move minus 3 inches in Y, and I'm not going to move Z at all. I'm going to rotate to a positive 45 degrees around the Y. Once I get there, I'll just mill my line. Mill, lines and arcs. Now I'm going to start at an X of 0. I'm going to start a Y of minus 0.625. I got a 1/2 inch or 1 inch end mill I want to use. I want to start off the part, closest to me, the operator, at least the radius of the tool or more, because I'm going to cut from me along the side of the part away from me so I can climb mill. I'll start at 0.1 and let's go down 2 inches just to make sure we go deep enough to clear all the material on that side. Probably don't need to go that deep, but what's it going to hurt? Okay, tool 5. Now I'm going to use cutter comp left here. The reason is, you see that I want to use the side of the end mill, and I want the side of the end mill to run along what I have created to be X0. Here we see that vertical black line that is Z is my X0, if you can think of it that way. So I want to run along that, and I want to keep the tool to the left side of that. So I use cutter comp left. My next segment will be a line, also to X0. I'm going to go all the way off the part. So I'm going to go the full 6-inch length of the part plus the radius of the tool, so 6.625, or a little beyond the radius of the tool. And then just like we've done everywhere else, next block is going to be a transform plane end. And you can see that I have just cut a chamfer using the side of the tool. Now that would be very difficult to use a large chamfer tool to get one large enough to do that. So to be able to use the side of just any standard end mill is definitely a plus.